Computer Science 226, lecture number 4, August 27th, Thursday. Today we're talking about multidimensional arrays. Okay, so I want you to read chapter 8 of your textbook, and today's will be more like a practice, I guess. Okay, so one more time. So what are two-dimensional arrays, right? So that's approximately what they look like when we have 2 dimensions instead of 1. When I want to create a table or a matrix, right? So the way we would create one, we would just say new int 5 by 5, or we would immediately specify the values. Okay, to assign the value 7 to a specific element at a row 2 column 1, here's what you need to do. You need to say matrix of 2 of 1 is equal to 7, and in this case this guy over here, this cell is going to have 7. How to initialize an array, right? Either do this or do this. Okay, another way of thinking about an array is that we used to have x of 0, which was just an element, right? Now it's becoming an array by itself, so it becomes this, right? So, but still x of 0, again, x of 0 becomes an array, right? Which means that you can basically query the length of that array. If you just say x of 0, that length, it's going to print out 4. Yeah, and that's what I want to kind of talk about in a bit more detail in the over here, right? So again, in order to do anything with the content of a two-dimensional array, you need to have 2 for loops. Let's come over here. That's what I was explaining for 190. Let me delete this. Okay, so let's say I want to create a two-dimensional array. I don't know of what, integers, right? Matrix, right? Okay, so int matrix is equal to new int. Okay, and now let's say it's going to be let's do it 4 by 5. Okay, 4 by 5. So again, it really depends on how do I say that? At the end of the day, what it means is that the first dimension is going to have the length of 4, and the second dimension is going to have the length of 5. Okay, so 4 elements in this first dimension, 5 elements in the second dimension. Now that's probably a little bit too difficult to understand, and that's why what we're going to do, we're going to pretend that the first dimension is rows, right, and the second dimension is columns. So in this particular case, when it's 4 by 5, kind of what I mean is that it's going to be, let me draw. Okay, so it's going to be 4 rows, 5 columns, right? So like a rectangle like this, and then so we're gonna have 4 rows like this. Okay, so 1, 2, 3, 4, and 5 columns. 1, 2, 3, 3, 4, 5. So 1, 2, 3, 4, 5, and yeah, so 5 columns, 4 rows. Okay, when it's 5, why am I showing you that example, not 5 by 5? I'm going to explain that to you in a second, in a little bit. Okay, so 4 by 5. Okay, now number 1, right? Initialize arrays with the input values. Okay, so what I need to do, I need to create a scanner first. So let me create a scanner. Import java.util.star. I'll do that, and then I'll create a scanner, right? So say how do I do that? Yeah, okay, scanner.input. Scanner input is equal to new scanner, and then system.in. System.in. That means that system.in means that we're going to scan from the user input from the console, right? Okay, I created those 2, and now I'm going to scan. Okay, so again, whenever we have a two-dimensional array, we need to use 2 for loops, right? So I'm going to use 2 for loops like this, and here I'm going to say usually that's how it works. Int I is equal to 0, I is less than, and I plus plus. Okay, and here I'm going to go to do the same thing with the j. Okay, so now the real question is what is I and what is j? So what is row and what is a column? Okay, So that really depends on how you're going to process the two-dimensional array. I'm going to process that in a way of, so I'm going to process it row by row, right? Yeah. So, for example, let me create a new slide. Okay. So it really depends on how you're going to process this. You can either process from left to right, row by row, and that's how I'm going to do this. So like basically from the very first element to the right, and then come back over here, and then also to the right on the second row, come back over here, go to the right, come back over here, go to the right. So you can do that, right? And that's going to be row by row processing. Okay, or you can do the opposite. You can basically process a column vertically by column. First column, second column, third column, fourth column, fifth column. And which will look like this. Over here, then come back. Over here, come back, go down, come back up, go down, come back up. Okay, so, and it's very important. Depending on what you kind of what you mean by I and J, that's what determines this, like IJ, what those IJ means and where you place those IJ. That's what determines the direction of processing to the array. Okay, so a most natural way, in my opinion, is to process that row by row, right? So that's what I showed you first. That's when you go from left to right, then you come back to the second row, come back down here, and then again go from left to right. Okay, so here's how it's gonna work. So again, what is the first dimension and what is the second dimension? Okay, so the second dimension is the columns, the first dimension is the row, right? So in the innermost loop, you should be traversing the dimension. In the innermost loop, you should be traversing the dimension which you change, which you traverse more frequently. Okay, what does it mean? So in this particular approach, you traverse from left to right, which means you traverse the columns more frequently than the rows. So in this approach, you need to traverse columns 5 times, and then you traverse the row, right? What does it mean? If you're traversing columns more frequently, that means the innermost loop should be traversing columns, okay? And columns is what? Is the second dimension, is this 5, okay? Which means that I need to process, and J needs to go from 0 up until matrix of 0 that length, okay, J++, okay? And what is, and why am I saying matrix of 0 that length? Okay, so what is, first off, what is matrix of 0? Matrix of 0 is the length of the first, no, hold on. Matrix of 0 is the length of the second dimension, right? Matrix that length is basically the length of matrix that 0. What is matrix that 0? It's this row, okay? So matrix of 0 that length is how many columns I have, right? So how many columns I have in one row, which is 5, right? That's why over here it's J going from 0 to matrix of 0 that length. Now another question I may ask you is, what if I change this from 0 to 1? Is that going to change anything? The answer is no, because the dimension of matrix, sorry, the length of matrix of 0, right, which is the length of the first row, the length of the first row is exactly the same as the length of the second row, as the third row, as the fourth row. All of those rows have exactly the same length, which is 5 columns. Okay, so I can do this, I can do this, I cannot do this, right, because that would mean that it's talking about the 5th row, right, but I only have 4. But usually the convention is that always saying matrix of 0. Okay, perfect. Yeah, so the innermost loop should traverse the second dimension, which is the columns. Okay, that means the outermost loop should traverse the rarest, the more rare dimension, which is the rows, which means it should go to matrix that length. Okay, and what is it? It is the length of the first dimension, which is how many rows I have, right? How many rows do I have? 4. Okay, perfect. Next. what I want to do, I want to initialize array with input values. Okay, so what do? I need to say, for example, system that out that println. Am I recording? Yes. I need to say, I don't know, enter. I don't know, some amount of columns, right? Rows. How do you do that? Yeah. Okay. So enter matrix that length rows and matrix of 0 that length columns. Okay, something like this. So enter matrix that length. Yeah, enter matrix that length rows and matrix of 0 that length columns. Okay, so basically in this case 4x5, 20 elements. Enter 20 elements. Okay, and after that I'm going to scan it, right? So I'm going to say matrix of I of j is equal to input that next int. Okay, perfect. And after that, let's try to print this thing out. Okay, I'll do even better actually, and that's what I recommend you guys do as well. Okay, I will create a separate method which prints out the array, two-dimensional array, in the right format. Okay, so I'm going to say public static void print 2D array. Okay, it needs to accept a 2D array AR. Okay, and then it's basically going to be the same thing. The structure again. So when I initialize the 2D array with values, when I print that out, when I changed it, always I use two for loops. I just changed like this particular the line in the middle. So I need to say AR, then here I need to say system.out.print, come on, print, okay, then do AR of ij, okay, and then space, and then okay, ln, perfect, printed the array. Okay, and now I'm going to do this matrix. Perfect. So now let's try to run this. Okay, 4 rows, 5 columns. Need a space here. 1, 2, 3, 4, 5, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Boom. No, didn't work. Did not work. So let me copy this. Boom. Boom. Awesome. Okay, so I printed out that in that nice, more or less nice format, right? So 1, 2, 3, 4, 5, 6 from 6 to 10, from 11 to 15, from 16 to 20. Perfect. Okay. So normally, again, in order to make it nicer, I need to make sure that like this 10 is over here and this 5 is also over here to make it a nice column, right? But we're not doing this now. Okay, perfect. So again, why did I create it 4x5? In order to show you the following mistake you can run into. Let's say you kind of forgot a little bit about this convention, and you change this I and this J, so you swap them. Okay, so let's see what's going to happen in that case. okay, yeah, it's going to have an error. Okay, why is this? Why did it happen? Because I confused I and j, I swapped them, okay, and now it's going to be filling out. It's going to be filling out not this way, but it's going to be filling out the table the opposite way, right? So column by column, okay. But the borders are still the same for the loops, okay. So it's going to think that I can go from the first dimension can go from 0 to 4. The second dimension will go from 0 to from 0 to 3, and the second dimension from 0 to 4, right? And it's going to expect to do the same thing. It's going to try to place the element over here, the element over here, the element over here, the element over here, and it's going to, again, since I swapped them, it's going to think that there should be space for the fifth element. It's going to try to place an element over here. And that cell doesn't exist, unfortunately. And that's why it's going to throw an error. Okay, so this wording, verbiage, index 4, out of bounds, full length 4, okay? So whenever you see in the Eclipse out of bounds, that's a hint, that's a sign. That means that the size of the array is 4, and you try to place the fifth element, right? Or the sixth element, or the element with the place -1, with the index -1. That's of course not possible, okay? Yeah. And here's kind of a tricky thing. Unfortunately, if you create a square matrix, 5 by 5, that mistake is much more difficult to catch. Okay, so let's try to do this. I'm gonna call it, right? Same thing. No. Now I need 25. Okay, 21, 22, 23, 24, 25. Okay. So you see, like, I swapped them, right? And it created this matrix. But now when I'm printing out that the right way, so I created the matrix the wrong way, but I printed that matrix out the right way. So check out what happens. Instead of going 1, 2, 3, 4, 5, it goes 1, 6, 11, 16, 21, right? So basically this matrix got transposed. 1, 2, 3, 4, 5, then here 6, 7, 8, 9, 10. Okay, so and again, it doesn't throw you any errors, and that's one of the potential issues you may run into. It's very difficult to catch, and then you can completely break your brain, like, while you're trying to understand this and that. So that's why be very careful about I and j and where they should be located. Same thing over here. For example, if I swap these two, okay, so I did this correctly, but I swapped I and j over here, and let's see what happens if I no, not here. 21, 22, 23, 24, 25. Same thing, right? So yeah, I can either screw up while I'm creating an array, or I can screw up when I'm printing it out. Okay, so it should be exactly the same in both cases. When I'm creating the array, when I'm using the array, when I'm printing that out. Okay, moving on, next part. So we got that, right? Initialize the array with random values. Pretty much the same thing, but even easier to do. Instead of scanner, so I don't need to use scanner. I can comment that out. Right? Why didn't it comment out? Huh? Hold on. Okay, that's good. Okay, perfect. So I need to have random. Method random, right? Okay, yeah. So I need to have int math.random. Okay, and I need to multiply by 100, right? Not sure if you remember, but math.random creates a double valued number between 0 and 1, not including 1. So basically 0, 0.1, 0.2, 0.15, 0.00001, anything between 0 and 1. Exclusive 1, right? So not including 1. So basically between 0 and 0.9999999. So that's why if I multiply it by 100, I'll get some decent number, and then I can typecast it to an integer. Random. Why random is not there? Probably need to import it. Java math, right? Let's try to run it. No. Random is undefined. What? Ah, okay, sorry. Lowercase. Okay, cool. Perfect. Yeah, again, exactly the same thing, which proves my point. Whenever you try to do anything with a two-dimensional array, use two for loops. And then we come into printing out the array. How do you do that? You do it exactly this way, the way I showed, right? Again, two for loops. Basically, again, this structure is going to be exactly the same. You just need to change the line in the middle. And now let's talk about like what this println is about. Okay. So again, since I want to kind of create a more or less nice way of printing out the two-dimensional array, I want to print out like one row, then go to the next line, second row, go to the next line. Okay. Now, if well, this is probably the most intuitive way of printing out an array, right? So let's see what this leads us to. Okay, so unfortunately, I just printed all numbers out, right, in a row. That's what this does, and that's not really helpful. That doesn't even look like a table. It doesn't even look like a matrix. So in order to, and why is that happening? It happens because I print out an element, put a space, right? Print out an element, put a space. Once I finish my first row, nothing changes. I just add one more space and I keep printing out the second row, right? And that's why I need to go to a new line whenever I finish printing out the first row. How do I know when does it go to when does it go to the next row? It goes to the next row after it stops processing, after it finishes processing the first row. And rows are processed in this innermost for loop. That's why if I introduce println, right, you can basically print out a new line. After every row is processed, it's going to make the terminal go to the new line, the carriage return. And that's it, right? Yeah, perfect. Okay, so it's actually added 2 now. Perfect. Okay, hope it makes sense. I have a assignment for you, separate assignment. No pressure, don't have to do that. Highly recommend doing this though, because again, you guys do not have labs this semester for this class. In a game of tic-tac-toe, 2 players take turns marking an available cell in a 3x3 grid, right? 3x3 grid sounds like a 3x3 array, with their respective tokens, either X or O or 0. When one player placed 3 tokens in a horizontal line, vertical or diagonal row on the grid, the game is over and that player has won. A draw, no winner, occurs when all cells on the grid have been filled with tokens and neither player has achieved the win. Create a program for playing tic-tac-toe. Okay, so I'm going to give you, let's say, I don't know, 1%. Yeah, let's do 1% of extra credit if you guys complete this task where you'll be playing against artificial intelligence. So basically kind of user, me, you, whoever's using that game, will be playing against the computer. Basically what's going to happen is that the computer, well, so what you need to do, you need to create a two-dimensional array, right? And when a computer plays first, let's say a computer always plays first, and the computer plays with X's, crosses, and you plays with, and we play with O's, zeros. So computer goes first. You kind of need to randomly select a cell, right, in a table of 3x3 using random number generator, and the computer is going to place that X and it's going to print out. So like computer, like I don't know, first turn the computer and prints out that board. Okay, then a player is going to put 2 numbers, let's say 2, 1, and those will be the coordinates of the where he wants to place the 0, the O. Okay, and then this board is printed out again with 1 X and 1 O. Okay, now keep in mind that if, for example, the computer selected 1, 1, I should not be able to select 1, 1 again, right? So the computer, the program should return back to me and say like, hey, like you did something wrong, X is already there, can you please reselect it? Okay, and after that we basically then it's computer's turn. He is going to randomly generate again 2 numbers. but definitely they should not coincide with some other numbers which were generated, right? So for example, if he selected, I don't know, 1 1, I selected 1 0, then he cannot generate 1 1 or 1 0, right? So you need to exclude those somehow. And yeah, and then basically we repeat the entire thing until there is a draw or somebody wins, and then you declare the winner. Okay, so I'm gonna give you 1% of extra credit if you can solve this task and format the code well. Just whenever you're ready, send me an email with the code. Okay, that's it for today. I'll see you guys next time. Bye bye.